All right, well, welcome everybody to part 2 of understanding the 2015 Michigan Residential Energy Code. This entire series is approved for 3 hours. Each session is approved for 1 hour individually in continuing ed. My name is Brett Little. I'm the Executive Director at the Green Home Institute, and I will be your moderator today. The Green Home Institute is a nonprofit with a mission to make healthier and more sustainable choices in the renovation and construction of the places we live. And then a huge thanks to our sponsors, members, board of directors, volunteers, presenters. We could not do this without you. All right, so with that, I'm going to hand it off to Mike Holcomb, Green Home Institute's founder and former president, as well as Midwest and West Michigan-based home energy inspection assessor, who's going to be taking us through the new Michigan Code. And then tomorrow we'll be joined by Jeff from Panasonic, who's going to be talking about ventilation strategies under the new Michigan Code. Take it away, Mike.
Thanks, Brett. So briefly, this morning I'd like to start out with a little bit of a recap concerning yesterday. Yesterday we spent our time presenting the list of values that you must meet if you intend to build, remodel, repair, or install additions to residential housing prescriptively. Those numbers are pretty much cut and dried with no room for improvisation, and they include our values for attic insulation, ceiling insulation without an attic, framed walls, fenestration values, U values of windows and doors, foundation walls, the concrete walls, either interior or exterior insulation, and slab edge insulation. And all are narrowly defined depending on which of the 3 climate zones that you're working in. In Michigan, there are 3. There's 5A, 6A, and 7. And basically, the thermal envelope requirements in MUEC 2015 are the same as MUEC 2009, with the exception of the allowable air leakage, and that was changed from 7 air changes per hour at 50 Pascal test pressure to 4 changes per hour at 50 Pascal. So there's a reduction of a little less than 50%. Not a difficult improvement to make. One of the biggest prerequisite requirements is the requirement for all homes to be blower door tested by a third party. So today we're going to cover performance options for meeting the Michigan Uniform Energy Code 2015. And basically there are 3. And there's the projected annual cost equalization, where your projected annual costs for heating and cooling and water heating are equal to or less than MUEC 2015. There is also the energy rating index, or basically the HERS index, and then a variety of above code program or above code programs such as Energy Star version 3 or others, and we'll talk about those later. But regardless of what code or what pathway that you take, whether it's prescriptive or performance, there are still mandatory requirements that we'll talk about. And I've got a list of those that come to my mind, and basically we'll go through those in a recap at the end. But those mandatory requirements remain such regardless of the pathway that you take. So where we left off yesterday is a requirement, a mandatory requirement, and this would be for either pathway, is to have a programmable thermostat. And you are required to have 1 thermostat per dwelling with a range of 55 to 85 degrees. And you're to set it initially with a set point no higher than 70 degrees for heating and 78 degrees for cooling. And I guess there's an assumption that if the contractor sets that when it's initially installed, that the homeowner will leave it there. There's no evidence that that's true, but that's the initial set points that you need to have. I don't know of any homes that have failed that requirement on the initial set points, but it is in there if one jurisdiction were more diligent in their inspection process. That's what they would be looking for. This is another mandatory requirement. This has to do with heating and cooling equipment. It must be sized according to manuals J, D, and S. And manual J is to size the equipment. Manual D is to size your ductwork and how many supplies are needed in each area to get the required amount of BTUs in there. And manual S is the selection of the equipment. Those calculations need to be submitted to the code officials sometime during the building process. Many jurisdictions required at time of permitting. So when you submit your permit, you not only tell them how you're going to meet the MUEC, whether it's going to be prescriptive or performance. If it's prescriptive, as we talked about yesterday, you're going to have to submit a checklist of values that the code official will be looking for. And they may also require that you submit these calculations. Now, it doesn't have to be manuals J, D, and S. It can be their equivalent. And there's a variety of software programs out there that calculate these, and they're equivalent to manuals J, D, and S. What they're looking for in this is the specific equipment that they're going to be looking for. So if you've got a Bryant furnace, they're going to be looking for that Bryant furnace by a model number based on manual S selection, or Lennox, or Carrier, or whatever it happens to be. A lot of jurisdictions are looking for this information, and it quite oftentimes we're seeing it now showing up on the construction drawings for the project. And so it'll not only have these manuals selection numbers on the drawings, but they'll also have the thermal envelope value, the values that are being installed on those drawings too, so that they have all that information in one place. This is a new requirement. It's been required for a long time that you have the equipment properly sized, but now they actually spell it out. And in some jurisdictions, they want it up front. Other ones, they have to have it before you get a certificate of occupancy. As a reminder, if you have any questions, you can type those into the dialog box. You're all muted for sound quality, as Brett had mentioned. But at the end of the session, we'll look at the box unless it happens to pop up when it's relevant to what we're talking about. And I'll either go through that list afterwards, or I'll try to catch them as we go through. Ductwork. These are the requirements for insulation of the ductwork. If it's located within the building but outside conditioned space, it has to be insulated to an R6, and that would be places like unconditioned crawl spaces or in attics, and R8 when it's located outside the building. And that would be a condition like for a rooftop system, and the ductwork were out there. It needs to be an R8. And you have to have a minimum R8 between ducts and a portion of the assembly farthest from the conditioned space. So if you have a ductwork that's in a wall cavity, exterior wall cavity or floor cavity, the minimum insulation between that duct and the ambient air, if you will, would be an R8. So if you're running a second floor duct up through a garage connected wall, and you've got a 2x4 wall assembly, and you're putting in a 2.5 inch thick duct in there, you'd have to have an R8 between that duct and the drywall to the garage section. And that also would be considered duct outside of the building then. And the same thing with floors. If you've got a cantilevered floor over the garage space, or a sunroom, four-season sunroom that goes out, and you've got a duct run in there, you have to have a minimum 8 into that space. Now that's, since it is considered outside the ductwork, that would also trigger the requirement that you have your ducts leak tested, total leakage to the outdoors. And we'll talk about that in a slide or two coming up. There is a requirement in the code, as I was just sort of mentioning, that duct leakage testing is mandatory when the ductwork is outside the thermal envelope. Now, it's considered outside the envelope anytime you don't have full R value between the duct side closest to the ambient or outside the thermal envelope. So if that's a wall in the garage, if you can't get a full R13 with an R5 continuous insulation in that space, or an R20 cavity fill, that's considered outside. So prescriptively, the code then would mandate that your ductwork then be tested. Here's an example of the common wall between the house and the garage, and the garage is on the left of that cross-cut of the wall cavity, and the conditioned space is on the right. And the arrow is the wide gray bar going up is the ductwork, and the arrow is showing where the R8 minimum would need to be. Now, if you wanted that duct to be in the thermal envelope, then you'd have to change that R8 to an R20, which means that it might be beneficial to bulkhead that wall so that you can get a full R20 in there. Or if it's a floor cavity, if it were, then you would bulkhead it so that you could get a full R30. And you might want to consider different materials so that you don't have to add a bulkhead. You know, if you do as a dense packed, not dense packed, a closed cell foam insulation, you can put an R30 in there with 4.5 inches of material. So on a floor joist, it's a lot easier to meet that without building an actual bulkhead. Duct blaster testing. This is the device that we use to test for duct leakage to the outdoors. I'll see if I can improve the size of this a little bit. Obviously, any ductwork that's in the attic or in unconditioned crawl spaces is outside of the thermal envelope of the home. And even if it has insulation over it, if it's not full insulation and it doesn't have an air barrier to encapsulate that in an attic, then it's considered outside, and that triggers duct leakage testing. There are two pieces of equipment that are required to do total leakage to the outdoor testing. There's the blower door fan, which is on the left-hand side of that house. And then there is a duct blaster fan, which is connected to the ductwork itself. And the process involved here is that once the ducts are already in place and the grills, registers and supply grills are in place, the tester would come in, they would install a blower door to depressurize or pressurize the house to 25 Pascal pressure. And that's meant to equalize the duct blaster pressure of 25 Pascals, and then anything moving through the duct blaster fan at 25 Pascals would be going to the outdoors. And so that would negate any leakage into the home from the ducts and only isolate the leakage to the outdoors. The requirement for duct leakage testing totals, it can be done at, it can be done either during the final testing process, and at that point you would only be testing for total leakage to the outside during the process that I just described, and you would be allowed 4 CFM of leakage for every 100 square feet of floor space. So we count floor spaces from all conditioned spaces, even though it may not be considered a floor space based on the sales appraisal. So we do count conditioned space in the basement. And if it's a 3-story, you got a 1,000 square foot footprint, then it would be 3,000 square feet. 3,000 square foot home would be allowed, let's see, that would be 30, 120, no, I'm sorry, yeah, 120 CFM of leakage to the outdoors. And that is not a lot of leakage, especially if you've got ducts in an attic, because there can be a tremendous amount of leakage between the transition boot, the duct, and the register grill. And so it's really imperative that those areas get well sealed from the backside so that they can't leak into the attic. Flex duct doesn't leak as much in the runs as metal ducting does, but if it's not foamed and sealed properly where it's connected to metallic duct, and you're not going to do a really good job with 3 screws and mechanical tape or a zip tie, you really need to consider foaming those into place. because when they do the testing, they're actually going to leave the grill in place, but they're going to put tape across the grill. So any leakage around the grill, between the grill and the connection, or between the transition boot and the ductwork is going to magnify. And it doesn't take very much to get 120 20 CFM of leakage. And if your air handler happens to be outside the thermal envelope for some reason in a crawl space, then all of the leakage points in the air handler would be added to that total. So it doesn't take very much to get to 120 CFM of leakage in a 3,000 square foot space. If you also have the option of testing prior to construction completion at the rough-in stage. So you've got all your ducts in place, the air handler is in place, but you don't have maybe all the drywall's not up, or the transition boots don't have grills in them, obviously. And at that time, you might think, well, we'll test at that time so that we can determine where our leaks are and we can address those. We've experimented with that quite a bit, and it's extremely difficult for two reasons. One is it's hard to find leaks even though you can see the ducts, especially if there's the house isn't fully enclosed and there's any wind outside. Using tracer smoke, it's almost invisible at that point. But also the fact that the total duct leakage then drops to 3 CFM in that condition, and that's a standard of total leakage. It's very, very difficult to meet that standard of 3 CFM. So ideally, you would test it at the end if you're going to have ducts. Better than that, you would have all of your ducts in the bulkheads so that they're inside the thermal envelope and you wouldn't have to test. But there are situations, had a situation yesterday where we had to test duct leakage because we couldn't verify that the full R value was there because they didn't invite us in for a pre-drywall inspection. So if there's any way that you can avoid those conditions, it would be a good idea to do that. Oops, let's see here. Some jurisdictions will allow you to, if you're doing a performance-based, to actually model those spaces where they have less R value, where the ducts run through, and if they still, the performance value is still, cost of operation is still lower than MUEC 2015 or equal to it, then they'll allow you to do that without testing the ducts. But you'll need to check on that jurisdiction by jurisdiction. The question here is, are framed wall cavities allowed as cold air returns? Initially, when the code was written, it was not allowed. They required hard ducting on both supply and returns. And then there was an appeal because there was a conflict between the MRC and the mechanical code, and so contractors and the Michigan Home Building Association appealed to the Code Commission, and they said, yes, you can use frame cavities for cold air returns, even though it's spelled out that you cannot in the MUEC or Michigan Residential Code because of the conflict. And also, in addition to that, there was no evidence presented that using mechanical ducting on the cold air return side was cost effective. So even though it's written in the code that you can't, a ruling has come out that says yes, you can. So that was a quick changeover for the industry, and I don't know if it was for the better as far as indoor air quality and overall performance, but it is what it is. So you do not have to hard duct. However, air sealing is required, and that's required in every circumstance with ducts. And it has been required for some time, but it hasn't been spelled out in the, it's been mandatory under the mechanical code, but not under the Michigan Residential Code. So now it is in the Michigan Residential Code. So all ducts need to be sealed. And this slide shows you the areas where mastic or an approved sealant tape can be applied. And we also want to make sure that all the penetrations are sealed in the air handler itself, that we have a gasketed cover on the filter housing, because when we do our testing, whether it be for total leakage to the outdoors or just total leakage, all those areas are cumulative, and it doesn't take very many openings to fail a test. So penetrating lines through the evaporator housing, the return boots where they're connected to the air handler body, all of those need to be sealed. And they show all the joints sealed, but even the long seams on the duct runs themselves are best sealed if you want to keep that leakage to a minimum. So some of the areas that we typically find that fail in our inspections from a leakage standpoint is that they do not have the mandated covers on the filters, and there's a couple of different housings. The one on the bottom right, they actually have a metal crimped seal, but that's not really sealed that well. In my opinion, the only effective seals are the pre-manufactured housings for filters that have a gasketed seal on them that work well. These are some of the examples. Now these are high efficiency media filters, but they also have filter housings for the standard 1-inch filters that you might consider installing. The fresh air intake from ambient into the cold air return side, if you install those now, they have to have intake air dampers on them, so that when the air handler is operating, the damper opens up electrically, and it closes when the air handler is off. The gravity dampers, if they're allowed, they typically result in too much air leakage through them when you're doing the duct leakage testing. They can account for 30% of your leakage to the outdoors if they don't seal. So mechanically operated dampers are the best option for air intake on furnace. Now, if you have an ERV into the home, or an HRV recovery ventilator, or an energy recovery ventilator, then these dampers aren't required at all. This is an example of some air sealing detail. The one on the left is an insulated duct in an attic space, and they've got flex duct to it, and you can see that they've judicious use of mastic to seal those connections to prevent any leakage. And it's much better than the tape that they use. Mastic, it's a little bit more of a manual process, but it's done with a paintbrush, and it'll stick where the tape may have a tendency to fail when it's in an environment where there's excessive heat and cooling changes or even condensation. And then the two on the right, the right top picture is a duct tape. It doesn't appear to me to be an approved duct tape, mastic, but the bottom one is a better example of every joint being sealed with a mastic. Not only the transition connection between the down drop and the 6-inch duct, but also every seam on that 90-degree angle there. The top left here is ductwork that's in the attic, and it's been air sealed with a closed cell foam insulation, and that in effect is a reverse bulkhead. The problem with that is those ducts would still need to be tested because they don't have full insulation value of the ceiling, which is an R38. So if the ducts were laid down so that you could cover them after they've been sealed like that, then that would be an acceptable method of avoiding testing, because it's considered a bulkhead. Otherwise, you can see how they're painting a mastic on that connection in the attic before they stretch the insulation over the top and band that into place. it's very, very important that everything else be sealed with a mastic, because it doesn't take much leakage to fail a test. And then on the bottom right-hand corner, that is a penetration that's coming through a floor of an unconditioned crawl space. And you can see that they have used mastic and caulking around the transition boot at the OSB, and then they seal it with a mastic around the top so that there's no leakage between the transition housing and the floor material that might sneak past a sealed register grill. There's another floor connection on the bottom left. Really, this air sealing is important because heating and cooling systems are going to be closer to being properly sized instead of being oversized. Oversizing is oftentimes compensating for these types of leaks in the duct, because if it's a well-sized system, it's going to be much smaller based on the heating and cooling loads of a well-insulated and air-sealed home. So it's more important to get that conditioned air to the living space which is occupied, so that rather than leak into wall cavities or floor cavities of a home where it doesn't benefit the occupant. So a good job of air sealing is important, and I'm happy to say that in the 30 years that I've been doing home performance inspections, that it is getting to be more and more commonplace to see really good air sealing detail by the mechanical contractors. So it's a good idea to have the conversation with your contractors to make sure that your home doesn't have problems if testing is required, or performance problems if in fact the occupants enter a home that hasn't been tested for duct leakage, just to ensure that they've got the conditioned air going where it's needed. This is just an example of a method that one builder has used, and this is obviously a retrofit on a home, but it is a method. They've used closed cell foam, and if this foam has the proper fire ratings, it's all right to go ahead and use that on evaporators and odd units that need to be filled. This is an attempt to get a sealed layer on ductwork so that the proper amount of conditioned air can get to the right spaces. And I think that they're overcompensating here for poor duct design. That trunk coming off a secondary trunk and the truncated plenum on the top of that furnace are examples of poor design, and they're compensating. But the purpose of the slide is to show you that you can air seal these if you don't want to go through and paint every joint with a Class 1 fire rated material that's suitable for duct sealing. In February 8th of this year, when the new code went into effect, we outlined the testing options that are in the code for ducts. And as I had mentioned before, the testing options are rough in with the air handler, rough in without the air handler, in post-construction. And the common thought at that time was that the best time to perform duct leakage pressure testing was at rough end before the drywall was up, so that you can address those types of leaks before you cover them with drywall, so that there's the problems are taken care of before they get covered up. And so we went about testing ducts for 3 or 4 months, both prior to the code implementation and then for about a month after, just to find out, is that really the best time? And I would have to say that from my experience, the best time is not at rough construction. It goes against conventional wisdom that, oh, we can see it, but it's very, very difficult to track leakage in an environment that is cold and windy. And quite oftentimes, houses are not fully, well, they're not drywalled yet. So if there's any wind outdoors and you can't shut that air off into the house, especially if the garage doors still hasn't been installed or the house isn't sided, any duct leakage is masked by even the slightest bit of wind. we had a home that we tested at least a half a dozen times. The total leakage was about equal to the total output of the furnace, about 1,500 CFM at 25 pascals. We never could isolate that leakage under that environment. And so we went back in the spring after the house was completed, and we tested total leakage to the outdoors, and it was well within the limits allowed. But total leakage, we could never get it down to where it needed to be. And one of the issues that we find with comfort in homes is a lot of contractors over the years, anytime they brought a duct under supply under the cabinetry, either in the kitchen or in the bathrooms, they simply dumped it to the space and then put a grill in the toe kick that wasn't connected directly to the duct. So the space underneath the duct would be, or underneath the cabinet would be pressurized, and some of it would leak out at the toe kick, and if somebody were standing there, they could feel the air leaking there, or the conditioned air coming out of that grill, but it was never the amount that was designed to come in, where a lot of it would leak out rim band joists behind the cabinet or slip under the cabinets and just never reach the conditioned space. And so we oftentimes get comfort calls from people that say, yeah, I'm in my bathroom, or in the laundry room, there's a cabinet there, and it's just cold on my feet all the time, or I'm in the kitchen doing dishes and my feet are cold, or I'm prepping food and my feet are cold. And so that's what we go to the house, we'd find out that although that was an allowable practice, it wasn't a very good practice. And so retrofitting those ducts to be connected to the grill at that point is very difficult to do. So it's a great idea, just plan it from the beginning. We're seeing more and more that those ducts are grilled right up to the toe kick, and it's a much more positive experience for the occupant of the home. It's much more energy efficient, and you can control the amount of total leakage. Circulating hot water heating systems are required to be insulated, and that's covered under R403.4.1. This is the traditional hot water recirculating system. We don't see a lot of those anymore. Occasionally we still find them, so those are the requirements. I've got to catch up with my slides here. All recirculating service hot water piping shall be insulated to at least an R2. Circulating hot water system shall include an automatic or readily accessible manual switch that can turn off the hot water circulating pump when the system is not in use. The exceptions to that are factory installed piping with HVAC equipment tested and rated in accordance with a test procedure referenced by the code, or run-out piping not exceeding 4 feet in length and 1 inch in diameter between the control valve and the HVAC coil. Do not need to be tested, or I'm sorry, do not need to be insulated. Okay. Prescriptive hot water piping. Let's see here. Sorry for the delay, my computer's acting up here. Insulation for hot water pipe with a minimum thermal resistance shall be applied to the following. This is an R3 piping, or R3 insulation, should be applied to the following. Piping larger than 3/4 of an inch nominal diameter. Piping serving more than one dwelling unit. Piping located outside the conditioned space. Piping from the water heater to the distribution manifold. Piping located under a floor slab or buried piping, and supply and return in recirculating systems other than demand recirculating systems. So that's the requirement for R3 water piping insulation. Next we have fireplace. And these are mandatory requirements for fireplaces. If you have a new wood-burning masonry fireplace, it shall have tight-fitting flue damper and outside combustion air. I think that's, I don't think that's a new requirement. Outside combustion air has been good practice for a number of years, and now it's going to be something that's called out in the residential code as well as in the mechanical code. So under residential now, tight-fitting flues and outdoor combustion air. Tomorrow we're going to have Jeff from Panasonic come in, and he's going to talk about mechanical ventilation options. And I'm just going to I'm going to kind of gloss over this because Jeff is going to cover the options in detail. Just be aware that mechanical ventilation is required in all homes, residential construction, and the mechanical ventilation then needs to be set for the required number of air changes per hour based on the size of the home and the number of bedrooms. So there's section M1507 of the code, mechanical code requires it, and it's also in the residential energy code. And rather than discuss the options, I'm going to just say that they have fan efficacies that are required. You must meet a certain requirement for CFM per watt of power, and there are many fans options available on the market that work. Energy recovery ventilators and heat recovery ventilators are not as forthcoming in listing the fan efficacies, although I did find that the one that we see most often being Renew Air has theirs listed as 4 CFM, which certainly meets the requirement. Others, not so much. So just be aware that there is an efficacy that's required, and make sure that your mechanical contractor provides that information to either your third-party inspector or the code officials, or better yet, to you, so that you can distribute that information as needed depending on how you meet the code. There's, it used to be that mechanical ventilation was based on the square footage in bedrooms, and you actually had a calculation where you could use 1/100th of a CFM per square foot, and then 7.5 CFM per bedroom plus 7.5 CFM. Now they actually have a chart in the mechanical code that gives you a range of square footages in bedrooms, and then gives you the required amount of ventilation. And you can see that for the average home that we would see is probably 3 bedrooms and the 3,000 to 4,500 square foot, requiring 75 CFM. That is a lot of mechanical ventilation. And I expect that in the years to come that the people that write code will be evaluating ventilation to make sure that we're not over ventilating at too high of a rate, because it impacts comfort and indoor air quality if it's too high as well as if it's too low. But anyway, the chart's available there, and that's what they'll be expecting to see, a system that can provide that type of ventilation. That's the efficacy. This is an intake-only system. Jeff will be covering these. Exhaust-only system, and then mechanical ventilation is ERV. So that takes us into the area that I wanted to go next, and this is some of the performance options as opposed to prescriptive, because all of those things, yesterday we talked about prescriptive values of thermal envelope and fenestrations and that type of thing. So far today we have actually covered the mandatories regardless of which way your performance path, your performance or prescriptive pathway that you take. But now we're going to talk about some of the performance pathways. And the first one that we're going to talk about today is the Maximum Energy Rating Index. And if you've been building your homes with Energy Star or HERS score, they both use an energy rating index, and they use the Home Energy Rating System or HERS score. That alternative compliance is listed under R408-31071A in your code book. And basically, the HERS index is a rating scale of 0 to 100, where 100 is a code home and 0 is a zero energy home. And every 1 point reduction from 100 is a 1% better performance improvement. That's the theory of the index. So if you build to a HERS index, regardless of how you build, regardless of the thermal envelope values, the window values, this system takes into consideration the efficiency of the water heater, the furnace, and the air conditioner. So anything above and beyond code in efficiency helps reduce your annual energy cost to get you on target with the prescriptive pathway. So you were taking in these high performance situations, and also if we have a better performing window or higher R value in the attic, then we may be able to do less values someplace else in the home. So if you build a home and you're building in climate zone 5A, and you hit a HERS rating index or energy rating index of 55, then you're deemed to comply with the code. And if you're in 6A, that HERS index is 54. And if you're in the UP and you have a HERS rating index of 53, you're deemed to comply with the code. Now, having said that, the HERS index is changing as of January 1st of 2017. Prior to that date, they've been using the base reference home is IECC 2006, and so we're looking at a 50% improvement or 45% improvement for climate zone A or 5A over that 2006 reference home. Well, as of January, they're going up to the 2009 reference home, which basically is our code home now. So it's going to be much harder to hit that target of 55. Because the HERS index, depending on the size of your home, is now going to be on an average of 2 to 6 points higher. So if you're consistently hitting a HERS 55, that now could be a 57 to 61, which means you wouldn't comply with your code from this point forward. So if you're using the HERS index, and there are a few people that do that, have your energy rater, your HERS rater, model your homes under that new software to find out if your homes are still going to be in compliance using that method. The HERS index looks at thermal envelope, air tightness, mechanical efficiency, and the heat recovery, if you're using that, efficiencies, the efficiencies of the furnace, water heater, and air conditioner, and all of those things help reduce the cost. Whereas the performance pathway, or the old res check pathway, which is no longer being used, at least as far as I know at this point, wouldn't allow you to take those higher efficiency systems into place to offset your energy costs. So the HERS rating index is one system that you can use, but just be aware that that system is changing, which is literally going to make your code more stringent, because now you have a different baseline home to model against. So builders have the prescriptive path with blower door testing and duct leakage testing. That is one builder option for meeting the code. The next option is the HERS performance path, which we just talked about. That does require both the blower door testing and duct leakage testing in all homes. It doesn't matter if your ducts are inside the thermal envelope, you still have to do duct leakage testing under the HERS protocol on every home that receives our HERS index. So in addition to that, you have modeling and minimum prescriptive R values that need to be done under HERS. So that is a way, but it's also going to have increased testing requirements that you don't have under the prescriptive method of the MUEC 2015. Energy Star version 3 is another option that builders have. At one time, I think in 2011, Energy Star homes were about 30% of all new construction. And then they switched over to Energy Star version 3, and that dropped off in Michigan to 2 or 3%. There's been some increase since that date, but there's a lot. It requires all of the HERS requirements, which is duct leakage testing, blower door testing, minimum prescriptive R values in some areas, plus modeling. You have to have windows, furnaces, air conditioners that are Energy Star compliant. A lot of the windows, since Energy Star changed their U values from 0.35 to 0.32, many of them have not been tested as being approved by Energy Star. So you could be putting in a qualifying window, but the sticker wouldn't indicate it as Energy Star in this climate zone because it hasn't been tested. So Energy Star also has some framing requirements, value-added framing, 2-stud corners, that type of thing, that aren't traditional construction, but maybe should be, but they're mandatory in that program. And then we have other above code programs like the NHB's green program, which is spelled out as an approved code alternative program. And then there are others that have been applied for by Green Homes Institute and the Michigan Home Builders Association that haven't been approved yet, but there are things like Lead for Homes, Michigan, or a higher HERS score of 67, different programs, but they haven't acted on them yet. So just so you're aware of that, the options right now are Energy Star version 3, the NHB Green program to a silver level, and then the HERS index, the rating index. There's also one prescriptive pathway, or a performance pathway, that is done with energy modeling, and that energy modeling says that if the projected annual heating and cooling cost by approved software projects a heating, cooling, and water heating cost less than or equal to MUEC 2015, that you can take that pathway. And basically that requires modeling, blower door testing, and duct leakage testing under those conditions of it being outside the thermal envelope. And those 3 reports literally can go to your code official and meet the code without having to do a HERS or an Energy Star or prescriptive pathway. So a lot of our builders, since the thermal envelope has the same requirements of MUEC 2009, they're still building with 2x4 construction without having a continuous thermal barrier on the exterior. They haven't jumped to 2x6 construction, although you may want to for whatever reason, but it's not required. It's all about energy savings, and what they look at in those energy savings are the efficiency of the furnace, the higher performing windows, the efficiency of the air conditioner, anything above a SEER 13, and your efficiency of the water heater. So most of the builders that I currently work with are going that pathway. It's the IECC 2015 or MUEC 2015 equivalent. And the software allowed for that is REMRate or REM Design. So your HERS raters can offer you that option. And the only reason to offer you that option is the cost savings one and reduced testing requirements, because duct leakage testing is not required to go that pathway if the ducts are all within the thermal envelope. These are the mandatory requirements, even with the performance pathways. And you still have to pass all of these sections. You have to do the annual energy cost check and show that your house is equal to or less than MUEC 2015. You must pass duct insulation R-value checks if your ducts are outside the thermal envelopes. You must have U values and solar heat gain coefficient checks, which meet the requirements. So your windows still will be a 0.32 or better. Your home air infiltration must be less than 4 CFM. Air changes per hour at 50 pascals. 4 air changes per hour at 50 pascals. Duct leakage must pass if it's required. Mechanical ventilation must be installed. The efficacy of the mechanical ventilation must pass, and the mandatory check boxes, which would of Michigan IECC, must be met, which would be things like 75% of your lighting must be high performance lighting, either CFLs or LEDs. So those still need to be done under all circumstances. And what does this mean to the builders? Is typically that your costs are trending up, and those costs that are trending up are in the cost to build. So if it drives up costs, then you obviously have to take that into consideration, whether it be for testing costs, verification costs, or an actual building cost. Because if you're not used to doing these things, you're going to have to start doing them. And I'm talking about things like air sealing your ductwork, installing an interior air barrier as well as an exterior air barrier. Whether or not your jurisdiction looks for it on the interior, it's still required in the code under table N1102.4.1.1. It's on page 447 of the Michigan Residential Code 2015, and it's the first item. It says a continuous air barrier shall be installed in the building envelope. Now, we already know we have to have one in the exterior building envelope, and you have to have the tie vac or a drainage plane all has to be sealed. Those types of things, we already know about those. Everybody's doing those. But on the inside, the air barrier is also called for. Now, whether your code official calls you out on that, whether the rim band joist, they call you out and say, well, you can't have fibrous insulation or not, that's our interpretation of the code. That's the interpretation of about 18 of the 20 jurisdictions that I work with, that there must be an interior air barrier. So you either have to have foam insulation in the rim band joist, or you have to box it in with OSB or another form of rigid air barrier. That is up to the local code jurisdiction. Make sure that you talk to them about that to see if they're enforcing that part of the code, because they are the final authority. And it's a lot easier to foam a rim band joist than it is to try to cover it at a later date with a rigid barrier at the end of inspection, because it's manually intensive to cut all those pieces to fit, especially with today's I-joist systems. So from the perspective of the code, we have reached the end of today's session. So if there's any questions out there, I'll be happy to answer any of those before we close. Tomorrow, as a reminder, the starting time will be 9 o'clock Eastern Time, 8 o'clock Central Time. And we will be talking, the presenter will be Jeff from Panasonic. And he's going to talk about the different options for meeting the mechanical ventilation requirement. This is important stuff because for a couple of reasons. One is, as we tighten up our homes, the need for mechanical ventilation becomes more and more apparent. And how you provide that ventilation in a cost-effective way is going to be determined by the equipment that you select. And cost-effectiveness is based on the lifetime operating cost as well as the initial upfront cost. And quite oftentimes, we avoid the best options for ventilation to save a few dollars in the front. But the overall operating cost, the effectiveness of the ventilation system are oftentimes secondary to that. And it's maybe in your best interest as a builder to say, look, this is the minimum requirement, and this is the way our default position for providing mechanical ventilation. but here are some other options that will provide you with healthier, more energy efficient mechanical ventilation, and offer that as an upgrade or an option so that all of the information is presented to your prospective clients, and they're given the choice. And I found that clients will always make the right decision when we give them all of the pertinent information that is in their best interest to consider. So, Brett, are you still with us?
Yeah, I am, and I wanted to take some time for questions, and as the questions are coming in, I wanted to cover one more aspect of that above code, if that's all right with you.
Sure.
Okay. I think the slides are in here. So yeah, so the one of the above code applications I wanted to focus on was the ICC 700 2012 Silver, under the other name, the National Green Building Standard, which is an aspect of the it used to be owned by the National Association of Home Builders. Now it's a program managed and run and promoted by the Home Innovation Lab, which, from what I can tell, is a subsidiary of the National Association of Home Builders.
It used to be the National Association of Home Builders Research Center. They changed it to the Home Innovation Lab.
Exactly. So they changed their name and disconnected themselves in some ways. But so this program is growing significantly across the country as an alternative to LEED for Homes, which was a main green building program. It's an ANSI accredited program, so it's a little bit, which is one thing that many other green certifications, can't claim. And one of the unique things about Michigan is it's been recently just added to our low-income housing tax credit application as an alternative to LEED and enterprise green communities. And so we're already starting to see interest in this program, both on the low-income housing, single-family, and larger-scale affordable housing certifications. One thing to note about this program, too, is it uses an energy pathway that shows reduction above and beyond the 2009 scales. So you can see bronze is 15% better than IECC 2009, and silver is 30, gold is 40, and emerald is 50%. So the silver level is the one where the Michigan code falls in. And what's interesting about that and where the benefit might be is if you are using an above code green certification program. Again, this one is already pre-approved by the code. And then also, the other thing to note is that to get to the silver level, there are many different ways to get there. And using the HERS index rating and even blower door testing, in fact, is not required to get there. It's simply just based on a couple prescriptive pathway options that we discussed, basically outlined in the first session of this course, just by following the Michigan code, and then just have to use some sort of energy model. So you could use a really cheap, off-the-cuff, and I don't mean cheap as in cheap, but helpful Department of Energy home energy score. You could use REM rate, you could use BOPT, but you just have to use a valid energy modeling tool. It doesn't have to have blower door testing, though. That helps to get to this 30% silver reduction. And one of the ways that you might go say, so what, it's going to cost more to do a green building program, if you're not someone who's interested in doing one. So one of the benefits we think could be, again, getting the code official the registration for the National Green Building Standard, showing them it's certified, and then they're not up there messing around doing the full inspection for energy, which could be a value add, because sometimes code officials can have their own rules and own ways of seeing things. So if you've just got the certification completed, that could eliminate that problem. There could be potential tax incentives or tax credits. There was I believe a Senate passed 4 or 5 years ago, $5,000 incentive for people who build to this. It never made it through the House in Michigan, but it did make it with zero opposition. So if somebody were to take it back on, this could be potentially connected to that. And then the third thing is looking at larger projects, large developments where blower door testing is mandatory per every unit starts to become costly. So if you could use a program like this, which could also get your developer a reduction in mortgage rates from Fannie Mae, also could get you the ability to avoid that blower door testing and just do prescriptive inspections. Now, we certainly recommend blower door testing on every unit, but you could do a sampling or work with your assessor to do less and save some cost there. So that's one of the things we're working on, even though this is already approved by the code. That doesn't necessarily mean every local jurisdiction will accept it. In fact, we're running into skeptical jurisdictions because the code, the way it's listed, is one small paragraph in a 500-page book, and it is, in my opinion, worded, very odd. But I don't know if you had anything else to add to that, Mike.
I don't mean to this to sound like a rebuttal, but the Energy Code specifically calls out several mandatory items. And those mandatory items are there regardless of what for above grade program that you use. Mm-hmm. So it really is a matter of interpretation. Now you and I have talked to one former, or actually construction code board member that said if it's a program, then the mandatories aren't mandatory. But I have had several jurisdictions push back with that and say, look, we still want to see the blower door test results. We still are going to mandate that these mandatories are still met. So what they think that the difference is the energy performance as far as offsetting the prescriptive does not offset the mandatory. So you need to check with the code official that you're dealing with to say, do you accept this in its entirety, including mandatories, that we meet this prescriptive part of the code? And because I think that the code is written not with some ambiguity, that it's not clear that these mandatories can be just eliminated by using a HERS report or an Energy Star or some other third-party verification. Mm-hmm. So you and I know that we've run into different code officials that interpret that different. So make sure that your local code official, who happens to be the final authority, unless you appeal their decision to the Code Commission, you don't want to get to that point. You want to talk it out beforehand to make sure that they're on the same page with what you're trying to accomplish.
Yeah, I completely agree with that. So, is there any other questions here? Otherwise, we'll be reconvening again at 9 a.m. Tomorrow for those of you listening live. For those of you listening to the recording, all these sessions will be recorded and available on our YouTube channel, our USGBC channel. For those of you listening on demand, make sure to take your 7-question quiz to get your continuing education. And then that's all. Any other thoughts, Mike?
Well, one other thing is just be prepared tomorrow if you want to have any specific discussion, something's not clear, that you bring those to the table. After Jeff's session tomorrow, I'll be on just to answer any questions. I may do a little bit of a recap, but if there's any questions specific, it's a great time to bring them tomorrow so that you can have those answered in first person. Because sometimes questions, if you wait and answer for a written response, that actually could spur more questions from your end. So be prepared for a little discussion at the end if you choose to have it. Other than that, I'm done and I'm out.
Okay. Thanks, Mike. Thanks, everyone. We'll catch you on the next session. Take care.